Hello guys, welcome back to my channel, Memo African Motives. Still working on moments for engineering science N3. So in this case we have a question which is one from the question papers that we are going to be focusing on, actually on moments. So if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Memo African Motives. Okay, so we are given the first part here on moments, which is actually to define the term moment of a force. So if you are following our classes, you'll see that this definition, actually we talked about this definition for a quite long period of time. Anyways, for those who are new, that's the definition that we have there for the moment of a force, where you are referring that it is the product of the perpendicular force. So take note here, the product of the perpendicular force and the distance of the force from the fulcrum. That is actually what you are supposed to note. So these are the key words and points that you're supposed to actually take there. Okay, so that's for the definition. Then there on 2.2, that's where we are given a light horizontal beam, which is this whole figure is a beam that you're given. So we are given to calculate the magnitude of the reactions of supports B and E on 2.21. We need to calculate the reactions here, the magnitude of the reactions of supports B and E. So as you can note, yes, B is a support because it's actually facing upwards, and also E, it's a support, it's also facing upwards. It's an upward force. Okay, so let's analyze the diagram that we are given, the light horizontal beam. We are going to see that here we have a 5 kilonewton per meter, which is a distributed, also 5 kilo, also another 8 kilonewton, which is a distributed load again. So actually I refer to this, guys. Remember, we said it's best for us to just redraw this so that we can actually understand what's going on. Does it look like a beam? Okay, it doesn't look like a beam, so let us make it look much better. So we are going to just draw something like this. All right, so in this case we have, if you are to cross check the first part, we are starting here with a distributed load at A. There's nothing here, there's nothing at A, but you've got a distance between A and B. There's a distributed load of 5, which is in a distance of 3 meters. So remember, we're going to multiply 3 times 5, which is 15 kilo. 3 times 5, which is 15 kilonewtons. So we shall have something like this facing downwards, which is in between our A and our B. Remember, this was our B here, which is a support. So B is a support. This one, take note, B is a support. Okay, so this is our B. So in between here we have got a distance of 3 meters. All right, so now we multiply 3 times 5 and you got 15. So this is going to be 15 kilo. So you've got 15 kilonewtons in between here. All right, so let's just put this so that we remember that it was a distributed. Okay, then it's now distributed in between the distance. Now you divide the distance into 2 equal parts. Remember that. All right, so you're going to divide these 3 into 2. So 3 divided by 2, which is 1,5. You're going to obtain 1,5 from your calculator. So you divide this distance into 2. All right, then we have got a supported B, it's fine. Then we move on. There is another distance between B and C of 5 kilonewton, again in a distance of 2 meters. All right, so it's in a distance of 2 meters. So we're going to multiply 2 times 5, which is a 10 there. 2 times 5, that's a 10. So we are going to have a 10 like this in between B and C. All right, so this is actually in between B and C. So we shall have a 10. Remember, we multiplied, so this is now 10 kilonewtons. Remember, we multiplied 5 and 2, which is 10. Then the distance you divide into 2. So 2 divided by 2, that's a 1. Okay, so this is going to be 1 meter apart like this. We're going to have 1 meter apart. All right, something like this. Then this distance between is going to remain as 2 meters. All right, so let's just write 2 meters there, which is at C. But exactly at C, we can see that there is a force which is going downwards of what? 10 kilonewtons, which is at C. So this part here, there's a force of 10 kilonewtons, which is going downwards again directly at point C. All right, so that's what we have. We move on. This is 10, we represented it. So from C to D, there's just a distance, then a force which is going downwards at D, at point D. So we just have 3 meters in between there. So we've got 3 meters in between like this. We've got 3 meters. All right, then we represent this at D going downwards. That one we just repeat as it is because it's a normal, the normal force, that one. All right, so that's our point D. We've got 10 kilonewton again. Oh, 10 kilonewton. Just look at these guys. All right, anyways, then from D to E, we've got a distributed of 8. So it's 8 by 2, which is 16. Okay, so we're going to have 16 like this in between like this. We shall have 16 kilonewtons. So once like this, you won't go wrong. Then you divide the distance again, 2, because it's 2 meters in between. So you divide, that's 2 divided by 2, which is 1. So you're going to have 1 meter separated here between. Okay, 1 meter separated, but in between is just 2 meters as usual. So guys, remember that was also a distributed here, so that we don't forget. Then this is also a distributed here, so that we don't forget on the shear force diagram. Okay, so this one, now we have got the E, which is going upwards, okay, which is a support, this one at E. All right, so that was actually the diagram that you can end up with. If you choose to redraw some, they just work with it direct. Yes, it's fine, but it's best for you to just have something like this. Okay, so once at this point, guys, what am I going to do? That's the question now. What am I going to do at this point? Okay, back to the question. The question is, calculate the magnitude of reaction of the supports. We are not told that we are supposed to use a condition or whereby we're going to take moments on both supports. We are just told to calculate the reaction, so which means we can use the law of moments, then we can use also of forces. Okay, so we know that for moments we are going to take, let's just take moments about B. Okay, so let me just write this aside, moments about B. All right, so which are these moments which are about B? All right, so remember we have got the sum of anticlockwise moments being equal to the sum of clockwise moments, or clockwise is equal to anticlockwise. It's the one and the same thing. Okay, so why have I started with the anticlockwise? Because we know that this E is going in an anticlockwise, because if we cross check here, if we take this E, okay, this is our B here and this is our E, so it's like this. This is the support that we are taking from B here. So E is going to move like this, which is actually going in an anti-clockwise direction. Okay, that's what others were asking me to explain. Okay, so this is going in an anti-clockwise like this. This is anti-clockwise. Clockwise is like this, but this one is going anti-clockwise. Okay, so E is in the anti-clockwise with the distance of what? Remember, force times distance, which is this force, and distance 2 plus 3 plus 5 plus 2, just add 2 plus 3 plus 2, which is a 7. Okay, so we're going to obtain 7 times E. Remember, force times distance, so we're going to have 7 times E on the anti-clockwise, plus we still have another part in the anti-clockwise again. If you cross-check this, the movement of E, the movement of this at 50, this 15 kilonewton is going to move like this. So it's still like this, because anti-clockwise, remember, we are following this concept. So still it is in the same concept, because it's going to move like this. It's different from these ones, they're just going in the clockwise, like, but this one is going in anti-clockwise. So it's 15 back to what? To B, but 15 back to B, there's a distance of what? Of 1,5 in order for it to reach B. So it's going to be 15 times 1,5. Okay, so you've got 15 by 1,5, which is equal to, we take those ones in the clockwise now. So the clockwise ones are the ones that you have here. These forces, they're in clockwise. So 10 back to B. There's a 10 and a distance of 1 here, so it's 10 times 1. So all these ones, they are in the clockwise, so you're just going to take them. As you can see, guys, they're on the same side. So if this one is clockwise, definitely this one is also clockwise, definitely this one also, and also this one. Okay, so it's 10 times 1. So you've got 10 times 1. Just write this first stage, guys. Don't miss this part, right as it is. Then 10, also this 10 here back to B, so it's 2 meters in between. So it's 10 times 2. That's 10 times 2. Plus we move on to this 10 back to B. So we've got 3 and 2. So it's 10 by 2 plus 3, which is 5. So it's 10 by 5. So we've got 10 by 5 in this case, like this. All right, let's see another one. So we've got 10 and 5. So you're now left with 16 because you're back to B. So it's 16 back to B here. So remember, this was at 5. So it's actually 5 plus 1 because you're having this one. So 5 plus 1, which is 6. So it's 16 by 6. So it's plus 16 by 6. All right, so that's it, guys. Let's combine 7 times E, that's 7E, plus you multiply these 2, you're going to obtain 22,5. Okay, so 22,5, which is equal to 10 times 1, which is 10, plus 10 times 2, you obtain 20, plus 10 times 5, you obtain 50, plus 16 by 6, you obtain 96. All right, so I'm just going to combine these so that we don't mislead others. So let's just combine these at once. Okay, so if you add this from your calculator, you're going to obtain a total of 176, if I'm not mistaken there. Then I can transpose now this to the right hand side is going to be a negative. So 7E is equal to, you subtract because it was a positive, remember, so you're going to subtract 176 minus 225 in your calculator. This is going to give you 153,5. So you've got 153,5. Then actually what can I do to find E? I divide by 7. I divide by 7. Okay, so if I divide by 7, I'm going to obtain something like 21,929 kilonewtons. These were kilonewtons. Okay, so at this point, guys, you just have to make sure that you use a degree of accuracy which is specific. Okay, so you have just used 3 decimal places, that is to find E. So we used moments about B to find the support E. So you can actually now use moments about E to find the support B. But because, guys, here we are not told that we are supposed to do that, so we can actually use another concept to find what? To find B. To find B, because we now have this force, so we can actually use sum of what? Upward forces is equal to downward forces, because as you can see, moments, they take a lot of working, but if you are best to application of moments, therefore it's fine for you. You can also apply moments again. You're going to obtain the same answer as the one that we are going to obtain. So I'm going to use sum of upward forces is equal to sum of downward forces. All right, so these are the upward, so you can just write F up, sum of F up is equal to sum of F down, just like that. It's fine. Also, you can write in short. Okay, so F up, these are the ones which are going upwards, the ones that are pointing upwards. Okay, so it's B which is pointing upwards, this B and this E, these are the ones which are pointing upwards, so it's B plus E. All right, so we've got B plus E. We have already have E, which is 21,929. So we're going to have 21,929 like this, which is equal to F down. Okay, which are the ones that are going downwards? This one is going downwards, this one is going downwards. So we're going to add all these forces which are going downwards. All right, so it's 15 plus these 10 and 16 again. So it's 15 plus 10 plus another 10 plus another, remember there are 3, plus the last force which is 16. Okay, so you add everything here. All right, so what am I going to obtain if I combine these? All right, let's see what we are going to have here. We are going to have B plus 21,929 equal to, you combine all this part from your calculator, you're going to obtain 61. All right, so that means B is equal to, I transpose this, is going to be a minus. Okay, so I'm going to subtract this time, so it's 61 minus 21,929 like this. So it's 21,9. So you subtract, okay, you're going to obtain 39,071 kilonewton. All right, so this is what you're going to obtain for B. So that's it, guys. We have our B, which is 39,071 kilonewtons. All right, remember these are in kilonewtons. All right, so we have got our B there. All right, got our B. So what's next? Let's see the other question that we had is to draw the shear force diagram. All right, draw the shear force diagram. Remember, on the shear force diagram, the concept, guys, okay, let's just see how we are going to do this, guys, to have our shear force diagram. Okay, so I'm just going to start with let me just draw a line again so that I don't give this in another way. You just need something better there. Okay, something like this. Okay, so let's see. I need a shear force diagram, but if you are to consider here, okay, we remember this was actually a distributed here, so we know that when it is a distributed, it's going to be something like this. That's the movement in a diagonal like that. Okay, so we have got 15 kilonewton. We don't have, because at A here, take note, at A there's nothing there, which is A is actually at 0. Okay, so the point A is actually at 0 like this, because there's no force that is there, so it's actually at 0. But from A to B, there's a distributed now of 15. Remember, distributed always goes downwards. Okay, so this one is going to go downwards for how many? For 15 kilonewtons. Okay, so it's going downwards up to -15. All right, something like this. So let's say this is our -15 here. Okay, so this is -15. All right, kilonewtons. Then at this point, what happened actually is that if you are to cross-check direct from this distributed, we are now at B, which is a support. At the same, after the distributed, we are at point B, which is a support, which is going upwards. And we know that when you are going upwards, you add the given force. So we are going to add this force of 39.071 to -15, because we are at -15. Remember, we are at -15. So if we add this, because it's going upwards, so take note, guys, it's going upwards, so you are going to add, so you're going to have something like this, -15 plus the force at what? The force at B, this one, which is 39, the one that is going upwards, which is 39.071. So you add, so if you add, you're going to have 24.071. All right, so this is going to go upwards until it is at 24.071. Okay, so this is going upwards because it's a support, this one, so it's going upwards, direct upwards. Okay, until 24. So you just assume, let's just say this is our 24. Let's just take it upwards again, something like this. Okay, so let's say that is where we are now at this point here. This is where we are at 24. Remember, we said it's 24.071. Okay, so this is 24.071 kilonewtons. Okay, so this is where we are now. Remember, we said it's 24.071. Okay, so remember we are at B. Okay, so let me just indicate with a pen so that we will know where we are. Remember, we are at what? At B. This is what happened. So B is taken now. All right, from B to, we'll see that from B to C here, there's a distance of 2, but there's a distributed now. Remember, this is also a distributed that we had. So which means, remember, the distributed is going to go downwards like this, always in a diagonal manner like that. So if it is going downwards, which means we are going to subtract from the one that we had, we are going to subtract 10 for the distributed load. Okay, so we're going to subtract 10. So from this 24,071, we are going to subtract 10. So 24,071 minus 10, we are going to end up at 14.071. Okay, so this one is going downwards in a distributed. Remember, distributed always goes down like this, but it's going to be up to minus 14.071. Okay, so we are going to just assume that, let's just say this is where it is going to reach. Okay, let's just say this is where we are now. Okay, at this point, that's where we have 14 point, this is 14 guys, 14.071. all right, then what took place now after that? We are, remember, that was the distributed here. Then after the distributed at C, you can see that this 10 is going downwards, so you're going to subtract 10 direct, it is going downwards, this 10 that we are having here. Take note, guys, after the direct after the distribute, just like what we did, direct after this distributed, we had a support which was going upwards, so we had to add direct going upwards. So this one is going to go downwards direct, but how many units downwards? 10. So we are going to subtract 10. All right, so we are now at 14.07. we subtract 10, 14.071 minus 10, which is going to be at 4.071. all right, so this one is going downwards until 4.071. so you just assume that this is 4.071, guys. Let's just assume somewhere here. All right, let's just say that is where our 4.071 is. Okay, 4.071 at this point. All right, we are just assuming. Okay, because it's below this line, because remember, above the line it's positive, below this line it's negative. So that's what you're supposed to take note here. Above it's positive, below it's negative. So 4 point, it's still above the line, it's not below, it's above the line. Okay, then something happened after this 10. We had a distance. Take note, now this one is a free distance of 3 meters, so you're just going to move that free distance of 3 meters. There's nothing that was happening, so it's just a free distance. So let's just move, that's our free distance of 3 meters. all right, so you're at this point now, so which means it's actually on the same force of 4.071, because this one is just moving with the same force until that point of 3 meters. Then what happened after that? We went down, because this force is pointing downwards. So remember, anything that is pointing downwards, you subtract from what you are having. So this one is going downwards. Okay, so at this point of 4.071, we are going to subtract 10, but it's going downwards, so it's going to be direct going downwards like that. So at 4.071, where we subtract 10. all right, so if we subtract 10, we are going to be left with minus 5,929. yes, minus 5,929, something like that. Okay, so let's go downwards, guys, until minus 5, so as we are going downwards to minus 5, we must take note that this is minus 15. So minus 5, should be below, like should be a little bit above minus 15, so that it won't seem like you are doing a sketch there. You must do something that shows you are understanding what you are doing there. So it's just on top of what, because we know that if this is, let's say, minus 5, then minus 15, so it must also make sense also. Okay, not to say this is minus 15, then your minus 5 is here. No, that one it can't be. Okay, so this is the point where we are at minus 5, 92, it was 929. Okay, 929 kilonewton, like that. Okay, so we're at this point now. Okay, then what happened, guys? Let's see what happened. Let's see what happened here. If you are to cross check, there is a distributed before the support. This one, there's a distributed here which was there. Okay, so you're going to subtract because it's going downwards, but it's a distributed, so which means it's going to go downwards like this. Always a distributed, that's how you draw it. Okay, so you subtract 16 because it's going downwards. Okay, so at this minus 5,9, the one that we had, as it is, you subtract 16, the force that is there, this one, the one for the distributed, the one that you have multiplied, not the one that is written per kilonewton per meter. No, kilonewton per meter. You work with the actual force, the one that you multiplied, the kilonewton per meter, and the distance. That is the one that you're going to use. Okay, so which means from this force that we are now at, we are going to subtract 5,929. We subtract it was what, 16. Okay, take note, we are at 16, so we subtract 16. So if we subtract 16, we are going to be left at minus 21,929 from your calculator. So this is going downwards up to minus 29, but as you can cross check, this is minus 15. So actually minus 29 is below this line, actually below somewhere like this. So you can just have something like this. All right, yeah, because it's supposed to move like this, but if this is minus 15, therefore minus should be at least below that line. Okay, so that's, let's say, our minus 21. This is 29 or 21? 21 minus 21. Did I say 29 or 21? Okay, 21. This is minus 21,929 kilonewton. All right, so that's what we have there. So what happens at the end, we now have E, which is a support, and the support is going upwards, and whatever that goes upwards, it's a plus, so you add. So you're going to add minus 21,920. So if you add this, what is going to happen, guys? You are going back to 0. Okay, because you were at, remember, you are at minus 21,929 at the moment. So we add the force that we have, which is going upwards, which is this reaction here, which is 21, so by adding this, because it's going upwards, 21,929, we are going to obtain as 0 like that. Okay, so if you are to cross check, you started at 0, then you are going to end at 0. Okay, so this one is going to end at 0 like that. So let's draw it. It's going upwards because it's a support until it reaches 0 there. So let's just extend this line a little bit here. Then this one goes upwards. All right, so this one is going to go upwards. Okay, something like that, until it goes at 0. So this one started at 0, also this one started at 0 like that. So that's how actually you have to take note of the shear force diagram, guys. Whenever there's a distributed load, you are supposed to move with a diagonal line. You subtract that force that you have in between. Take note, guys, you had it as a 5 kilonewton per meter, so you just multiply 5 times 3, which is 15. So you're going to subtract 15. 5 times 2, that is 10. You're going to subtract 10. 8 times 2, which is 16. You're going to subtract 16 because it's going downwards, it's facing downwards. Anything that is facing downwards on the shear force diagram is going to be subtracted. Okay, so that's the concept that you have in this case. Anything that goes downwards, you subtract. Anything that goes upwards, you add. So that's what you actually have here. So for downwards, something like this, you subtract, that is your minus. Okay, then for anything that goes upwards, any force that is upwards, which is for the, actually, when, if anything that is going, it's actually, these are the reaction of, these are the supports, actually these ones which will be going upwards. You don't have another force that goes upwards which is not a support. So for all the supports, they'll be facing upwards and you add. So you're going to add their forces. So that's actually the concept, guys. You add, you subtract, you add. So that's the concept. You're adding, you're subtracting, you're adding. So whatever that you add or whatever that you have after subtracting, you represent it here, just like what I was doing. If I still have that part, I think I have taken it away, but let me show you this part here that I was having here. So you see that every stage I was actually noting it down so that you won't actually mistaken what you're doing. So that's actually what you need there. So guys, as you can see, that's what we had on moments from one of the question papers actually that I just looked at and said, let me just have it to you guys so that we can share this together and see if it's going to be helpful. So that's, guys, from Memo on African motives. Till we meet again.